All right, Mr. Ahmed here for Box and Whisker Plots. Our goal today is to construct some Box and Whisker Plots based off some data sets. And a Box and Whisker Plot's a way to display data along a number line that uses medians. The quartiles divide the data set into 4 equal parts. So our first quartile will be from the least value up until the median of the lower half. Right in the middle is the median of all the data, that's quartile 2, and quartile 3 is the median of the upper half, and then we also have the greatest value. So 25% of the data would fall between here, 25% here, 25 between here and here, and 25 between there and there. So we will get started. In order to construct a Box and Whisker plot, the first step is to order the data from least to greatest. Then we'll find the median. After we find the median, we'll find the upper and lower quartiles, which is the medians of the upper half and the lower half. Then we'll plot the minimum and maximum values for our whiskers, and we can have our Box and Whisker plot constructed. So we're going to take a look here at this first set of data. I've already ordered it from least to greatest. I actually made an error and had to do it again. I forgot a 16. So for us to find the median, first we'll find the median of the entire thing. We have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. And the median's between the 15 and the 15. So our median, or quartile number 2, is at 15. Our next step is to find the median of the lower half, or the upper half. Really, the choice is yours. Since I didn't use this 15, I have to count it as part of this. So here, 1, 1, 1, 1, and we're between 14 and 15. Which is quartile number 1. 14 plus 15 divided by 2 is 14.5. And then we'll find the median of the upper half. 1, 1, 1, 1, between 16 and 17. And that is 16.5. So quartile 3 would be 16.5 when we add those and divide them by 2. So now for me to make my Box and Whisker plot, I need to realize how far I got to go from. I got to get from 8 until 21. So I'm going to start at 8 down here. 9, 10, 11, 12, 13, 14, 15, 16. And all the way up to 22. So the first thing I'm going to do is I'm going to plot the median first. And my median, quartile number 2, was right at 15. So I draw a line here at 15 for the median, and that's quartile 2, which equals 15. Then I'll do quartile 1 at 14.5, which is very close to it. So quartile 1 equals 14.5, and then I draw a whisker all the way out to the lowest value, which is 8. And that's my minimum. And then we'll do the upper half. So the quartile 3 is at 16.5. And there's my other box. Quartile 3, 16.5. And then my maximum is 21. And we have constructed our Box and Whisker plot, which divided the data into 4 equal parts. So our next step is to look at a constructed one and interpret the data. So based off the data, we know that each part of the whisker is 25%. So 25% of the data lies between 5 and 9. 25% is between 9 and 12. And then between 12 and 15 is another 25%, and 25% for the last whisker. So what percentage of the data lies between 9 and 12? So between 9 and 12, 25% is. That's one of our quartiles. What percentage of the data is between 12 and 23? So from 12 to 23, that's 1 box and 1 whisker. That would have to be 50%. And the range of the data is the biggest minus the smallest. So our biggest number is 23, smallest is 6. And the range is 17. And the median of the data, right in the middle, is 12. An outlier. To determine if we have an outlier, what we're going to do is we're going to first determine the interquartile range, which is quartile number 3 minus quartile number 1. We then will multiply that by 1.5 and add the result to quartile 3. If there's any points outside that value, that would be an outlier. And if I subtracted any behind that, would be an outlier. So we will see if we have any outliers in the next set of data. So here we have the table below shows the average lifespan of 21 mammals. We are supposed to construct a box and whisker plot. So my first step is to order these from least to greatest. So I'm going to start ordering. I should have done this ahead of time, but I didn't. So it looks like I have a 1. Then I have a 3. And another 3. A 4. Let's see another 4s. A 5. Another 5. 6. Let's see any other of them. 7. 7. 8. Another 8. 10, 10. Another 10. I have 1, 2, 3 12s. Another 12. And another 12. And another 12. And a 35. Let's see if I got them all. I'm going to do a double check and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, appears as if I got them all. So first step, find the median. So halfway between the median, since I had 21, I'm going to count 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 8, 8, 9, 9, 10, 10. And it appears as if my median is 8. So I get to circle that one. Quartile 2 is 8. Okay. Find the median in the lower half. 1, 1. 2, 2, 3, 3, 4, 4, and we're halfway between our 5 and 5, so that would put us right here with quartile 1 being 5. And now the other way, 1, 1, 2, 2, 3, 3, 4, 4, 12 and 12. Quartile 3 is 12. So now I can construct my box and whisker plot. So for us to construct, start at the 8. And then I'm going to go over to 5. There's my first quartile. And the minimum value is 1. And now my upper quartile is 12. There we go. And then my maximum's all the way over at 35. All right, so we've constructed the box and whisker plot. Now, in order to do the interquartile range, I need to take quartile 3 minus quartile 1. And then from there, I get 12 minus 5. 12 minus 5 is 7. I then need to take 1.5 times the interquartile range, which we just found. The interquartile range is 7. Quartile 3 minus quartile 1. And when I get that, I get 10.5. And now from here, I'll take quartile 1 minus 10.5 And when I do that, quartile 1 was 5 minus 10.5, and that gets me negative 5.5. So that's out. We don't have anything below that. There's no negative lifespans. And now quartile 3, which is 12, plus 10.5. And that's equal to 22.5. Is there anything outside 22.5? Yes, there was. 35 is considered an outlier, since it's bigger than 22.5. All right. And lastly, looking at some double box and whisker plots, and what we have going on here, which shop has the higher range of prices? So for us to find the range, that would be the largest minus the smallest. So shop A would be 900 minus 300. And shop B, looks like we have 600 minus 250. And that is 350. So the higher range is shop A. What percentage of surfboards at shop A cost less than 400? So at shop A, less than 400 is 25%, because that's the first whisker. What percentage of surfboards at shop B cost less than 400? At shop B, that's right here in the median, so we have 25-50%. If you could spend up to $350 on a surfboard, which shop would you go to? Well, if I can only spend $350, I'd probably have to go to shop B because I have more to choose from. There's hardly any for me to choose from at shop A, so going to shop B. Because they have more for me to choose from at less than $350. What would cause this maximum at shop A to be so high? Perhaps they sell a different brand. They might have one super expensive one. I'm really not 100% positive exactly, but I'm going with different brands. All right, so that's kind of taking a look at a double box and whisker. We have 2 sets of data there. And I think we will call that good. We'll leave the last one for you guys to hold this thing off here at 12 minutes. Have a good one.